Welcome and thank you for joining me. In this video, I will be guiding you through an in-depth data science case study. Together, we will use data analysis to explore real estate data and predict property prices using deep learning techniques. So if you are working on Google Advanced Data Analytics Capstone project, this tutorial is a must watch. It will provide you with the momentum and confidence needed to tackle any data science task that comes your way. I am Ahsan and I specialize in teaching data science, data analysis and programming tools such as Python, R, MATLAB and Tableau. Our goal is to create a precise model for home sales prediction using attributes like bedrooms, bathroom views, square footage and much more. So you might be wondering, why should I join this project? Well, after you have finished the tutorial, you can add this as a capstone project to your portfolio and resume and can create an impression during an interview. I will guide you through understanding of the problem, processing data, building deep learning models and assessing models performance. You will develop a real estate price prediction model and gain confidence in your data science skills. Before we dive in, I would love your support. Don't forget to like, comment, subscribe to my channel. By doing so, you will be the first one to know about the latest tips and tricks. Without wasting any time, let's predict real estate prices using deep learning models and enhance your data science skills. First of all, let's talk about the data source or data set. Well, this data set has been taken from Kaggle and you can go to this link and read further about the data set. But we will discuss all things about data set, as this data set contains various features that provide information about different aspects of houses in King County, USA from May 2014 to May 2015 and contains many features like ID, which is a unique identification number of each house, date the house was sold, price, indicating the sales price of the house, which is actually our target variable that we want to predict this price on. Then we have bedroom, bathrooms, square foot living area, floors, waterfront views, how many times the property has been viewed or not, then the some condition or grading of the house and the year it was renovated and so on. So you get the idea. This is actually the data set that contains all important features about properties of a real estate marketing. And furthermore, it has the geographical location tool, as we have zip code, longitude, latitude. So this is a good and comprehensive data to study any real estate price prediction model. So as we have discussed our data set, the first step in any data science project or data analysis project is to actually count any or every libraries that we are going to use for the project. For this purpose, we are using Python programming language and we are using number of libraries that will help us for this to carry out this data science project. The first one is like pandas, numpy, seaborn and matplotlib. These visualization libraries help us create informative and visualizing appealing graphs and plots to better understand the data. Then we have math. Then we move on further to the scikit-learn modules. Scikit-learn is a widely used machine learning library that offers a range of tools for data pre-processing, model selection, and evaluations. And in scikit-learn module, we are using min-max scalar pre-processing technique that scales our numeric features to a specific range between 0 to 1. This ensures uniformity and help us model perform better. Then we have train test split, which actually splits the data into training and testing data set. And then we have performance evaluation metrics such as R2 square, mean square, error mean, absolute error. So these are the evaluation metrics that are used to assess how well our model is performing. They provide insights into predictive accuracy and generalization capabilities. Then finally, we will import TensorFlow and Keras modules for deep learning models. So we have TensorFlow, Keras, sequential. This is a fundamental building block for creating sequential models in Keras, and by the use of sequential modeling, we will define our deep learning model. So this is the actual code that we will import all the important libraries like pandas, numpy, using import pandas, then renaming it as PD, and similar for numpy as NP. And we are importing scikit-learn modules here also. You can see min-max scalar, train test split, R2 square, mean square error, and furthermore. And finally, we are importing TensorFlow and Keras modules. So you get the idea here. Basic libraries or that are used to carry out data science project, specifically to carry out and handle data frame short of data. And then we have scikit-learn modules, then we have TensorFlow and Keras modules. So okay, now we have good understanding. Okay, these are the essential libraries that we are going to use in a project. Let's move on to the first type of our project, that is to import our data set. For this purpose, we will use the method pd dot read underscore cfc. PD, if you remember, is actually our panda library, and read.cfc will help us read our CSV file. We are providing two input arguments to this. The first one is the actual path of the file and or the name of the file, and the second one is the encoding, which is ISO 88591. This encoding shows correct interpretations of the character when you are importing the data set. So okay, now we have imported the data set. The first thing we need to do in any to carry out any data projects, whether you are going for a data analysis, whether you are going for building a model, you have to pre-process the data. I mean, it can be like data pre-processing, it can be data wrangling, it can be data cleaning. Although these three terms have different kind of a meaning in a sense, but they can be used interchangeably. With data wrangling is like performing all the steps within the data science projects. I mean, data preparation. So we have data pre-processing that transforms the data into format that is more easily and effectively processed in data mining, machine learning, and other data science projects. So the first thing we need to do in order to do data pre-process is actually to look at our data set. Okay, what kind of columns we have, what kind of data is actually present in those columns, and how many rows are there. So in order to get just to look at the data set, we can use our df. If you remember that df is our data frame, and then we will use the method tail. Tail is a method that will help us extract the bottom rows of the data set. So, and we are defining 5 in the braces, which means that we only want to see 5 rows of the data set from the bottom. If we define like 5 instead of, we can do like 10, then it will give us the 10 bottom rows of the data set. So we have here df.tail, and we can see that we have number of columns and their associated values. We have IDs, which is the unique identification of the property. Then we have the date it was sold. Then we have prices, bedroom, bathroom, square foot, living area, and much more. And now, like after briefly looking at the data, there are a number of operations we have to perform in order to pre-process the data. And from looking at the data set, we can actually see right now that the date is actually not in the format that we would want it to be. We want it to convert into a date time format, which is with a format that is actually more readable and easy to visualize and understand. So as you can see that we have like years, then we have a month, we have days, then time. So we will need to convert this into a date time format. Furthermore, we want to furthermore standardize the column names. We will convert these column names into all uppercase, and if there is any white space present between the names, we will convert into remove that white space with an underscore. So okay. We will use df.info braces. Like info will give us all the information about the data set, a generic information like what are the column names and their associated data type. And we can see that date is actually an object type. So let's move on to actually pre-process our data. The first thing we will do, like we will standardize our column names and underscore spated words. That means that we will remove spaces and then use underscore in between them if there is any space present. So how we will do that? So this is the cell box that will perform the standardization. We will first use df.columns syntax to define a variable. So df is actually, you remember that is actually a data frame, and dot columns will tell this program, okay, we want to perform some operation on the data frame column names. Okay, so this is what is it. Okay, so like we are telling program we want to perform some operations on column names. Okay, so that's how we have df.columns. And what kind of operation we are doing? We are doing that on the left hand side. We are using map method. which will like convert this column names from lowercase to uppercase, and we provide two input arguments. First one is the str.upper, which is like exactly telling, okay, we want all these column names to be converted into uppercase, and the second argument is actually the values that we want to convert. And then like we are, for this purpose we are using df.column, that are the actual column name, and when the operation has been performed we are assigning this value back to df.column. So you get the idea here. That's how we converted those column names into uppercase. And the second thing, like we want to remove any white spaces that were present in the column names, then assign underscore to them. For this purpose, what we are doing right now, we are iterating towards all column names. For you are using for loop for call in df.column name. So it will iterate our each column name, and for each column name it will do what, it will replace this whites, if there is any white space present in the name it will convert it into underscore. And after like converting all the value, like it will assign back to df.columns. So right now we have standardized the names. So let's look at again by using df.tail. So right now we can see that actually the column names are converted into uppercase, and if there was any white space that are present in the column names, that would have been converted into underscore. That's good right now. So we have converted a column names. Next we want to convert is to actually convert this column date into actual date time format with syntax or notation that is more easy to read and grasp. For this purpose we will use this function cell blocks here, and we will use the same ideology which we have adopted in the first place here. Like we will define the assignment. Okay, we are taking data frame, then we are taking the column name, that is date, and we want to perform this some operation on this thing, so that maybe might be assign some different value to it. For that operation we are using pd to date time. So if you remember that pd is actually a Panda library, and we are calling the method to date time. Then we are passing two input arguments to it. The first one is actually the date column, df in braces date, and the second one is actually the format that has been used in our data set. If you look at this, we have %y, which is the number of years here, and then we have %m, small m, which is the number of month, 05, and then we have %d, which is the number of days, and then we have t here. T is to denote like the time format, and then but we can see that actually the time is actually all values are 000, indicating that this data set doesn't contain any time value. But if there was any time value, we can read the same notation like %h for hour, %m for minutes, and %s for seconds. Okay, so after like we have executed this code block here, and if we run this df.tail to see what are the values have been changed, now we can see that exactly the date for column has been updated with a format that is date time, and it is more readable to us. Now we can exactly see, okay, this is year 2014 and it's the year of month 5 and the date is 21. So we have standardized the column names, and we are now converted the date and time format. The next we want to do is to perform the data cleaning. So dealing with missing data is critical part of data presentation. We will create a mass of null values using isNull method function, and then calculate the total number of missing values. This insight will guide us in determining if and how we need to address these null values. So the first thing we need to do is to create a mask. What do we mean by mask? Mask is actually just like a form of indexing, that if you want to find certain values in a data frame, a mask will identify those values and store them in his directory. Okay, these the value, for example, in column date, in date column, and the sixth row has the null value or could be in anything. So mask is actually the index to those null values. So null, we will first assign a variable that is null underscore mask. Then we use the method is null to store all the index of those null values. And after storing the index, we actually want to count the values that are present. What are the actual total amount of null values that are present in our data set? For this purpose, we are using sum function here. And if you if you want to break it down, this function, it's just like that. Okay, null mass contains indexes of each column. Okay, when we apply this first method sum, it actually calculates all the values of all the values of null values that are present in each column. So basically it is will be a one by the order of column that are present in the data set matrix or array. So when we have that, or when we apply an additional sum function, then it will count all those values that are summed by column, and it will give you all the values, like the summation of all the values of null values that are present in a data set. And then we finally print the number of null values. Like if we can see that they are 0 null values, so it means that data are clean for null values, and we don't need to perform any further operations to count for null values. Okay, now we have checked for null values. The next thing we'll do, like we want to check for duplicate data. Duplicate data can skew our analysis and modeling results. We will definitely need to find out duplicate rows by creating a mask using dot duplicate method. The total number of duplicate rows that will help us gauge the extent of duplication in our data set. So just like in that we have used the null function where we get the index, in the same way we'll use dot duplicate to get all the rows that are duplicate of one another. So basically the duplicates underscore mass is actually the index of all the rows that contains duplicate values. So now if you want to calculate the total number of duplicate values, simply we will use sum amount function and calculate the duplicate values too. And when we do that and we will print the amount, we see that the values is actually 0. It means that the data set doesn't contain any duplicate value. So up to this stage right now, we have actually pre-processed our data. We have standardized the column names, we have converted the date column, and we have checked the values for null values and duplicate rows. So we are good to now for further proceed with our analysis. So the first thing we do whenever we first want to get an idea about the data set is to actually just briefly go through the data set. We have two important functions here, the df.info and df.describe. Provides a valuable insight into the structure and summary statistics of data sets. The info function offers a snapshot of the data types, non-null alicons, and memory usage of each column. So on the other hand, describe presents key statistical measures such as mean, standard deviation, quantiles of the numerical columns, giving us a sense of data distribution. So df.info, we have already used the df.info, and when we use df.info method, we can actually see it will give us all the column names here, and we can see that there are this much amount of column names, and they give you all the column names. Furthermore, it will also give you the range of the column names, like how many actually row entries are present here in 21, and it is indicated here 21613. And one important feature of this df.info, it also give you the data type that is present in each column type. For example, it give us this one is an integer, this one is object, this one is in a float. So give us the data type for each column. And as previously we have accounted for the null values, that we have counted the null values, you can further verify it, and you can also see through this description here. If there was to any a null value present in any column, the number of these columns would have been less than the actual value or the rows of the column. For example, let's say that our price has some null values. In that case, this number here would be less than the number of rows that are actually present in the column. It could have been 2000 or 1800,000, something like that. So you get the idea. And now the next function that we want to look at is df.describe, and it actually gives us more of a statistical observation of the data set, instead of more of a descriptive. So when we run this cell, it will give us a df.describe. And we see that we actually get all the column names that are actually present in the data set, from ID to square foot living and year builds, all that. But we have some kind of different rows, and we have in total you see that we have actually the count, mean, standard deviation, minimum, maximum, and quantile. The first row is the count, which actually gives the total number of entities that are present in the column. So for you can see that okay, for price we have exactly the same 21613 for all columns. And then we have a mean value, or the average value of the total data that is present in the data set. For example, for price we have like 5.4 exponential 5, which is the mean value of all the properties. Then we have a standard deviation, how much values are distributed, deviated from the actual value. Then we have minimum value. What is the minimum value that is present in a data set? For price, we can see that we have 7.5 exponential 4 dollars. That is the minimum value of a house in a data set. Then we have a maximum value here, which will give us the okay, what is the maximum value of this column? Or it could be a bedroom, square foot living area. So you can see that the maximum value of square foot living area is actually 13540. And then we see we actually have these quartiles. We have 25%, 55%, 75%. What does this actually mean? It actually means that okay, in a price column, 25% of the property prices actually lie below this value, this 3.21 exponential 5. So then 25% values are actually falling below this value. And when we look at 75% quantile, it means that actually the data set, the prices of the houses are distributed such that 75% of the values lie below this value. So it's actually kind of give a distribution, okay, this amount of data, this time amount of prices actually lie below this value. So that's what it means by quartiles. So we have a now generic overlook on our data sets. Let's move on to the important phase of data analysis or data modeling or machine learning modeling is actually exploratory data analysis. We will first begin with descriptive statics. Let's dive into descriptive analysis to explore and summarize the key aspects of data. Descriptive analysis shed lights on data patterns and trends. By asking specific questions and extracting information, we understand the data set's characteristics. Okay, so when you want to actually start a data analysis project, you always start with data questions. What is the thing you want to answer? This is a very key and important aspect of any data analysis project. So this here, like it could be anything. The questions could be anything that can answer any aspects of the challenge you are trying to solve, and anything that your stakeholder wants to get the answers on. For example, in this case, we are using, okay, what is the average house price? Okay, then calculate the average house price to understand the central pricing tendency. So, example, you have a location and you exactly do want to know what is the average selling price of houses in that area. And furthermore, you also want to like know what is the cheapest price and what is the expensive house price in that area, which could identify affordability and luxury options for that specific area. And then you move on to the further more generic questions. Okay, what is the average number of bedrooms and bathrooms that are present in this specific area of properties? So based on these questions, like these are just one of many questions. You can formulate many questions that you think that are more tailored to your business needs. For example, we have asked what is the average house price, and we use main function to calculate the average price. And then we've asked the cheapest price then by using min function. And then we have calculated the average bathroom and average bedroom numbers. And finally, we have calculated what is the maximum bedrooms that are available in the data set. And we use print to display the actual values. From this data or from this descriptive analysis, we can see that the cheapest house price is actually $7,500, and the average house price is actually $540,000. And the average number of bathrooms is 2, and the average number of bedrooms is 3, and the maximum number of bedrooms is actually 33. So this is after doing the descriptive statics, we will further move on to the study. We will further move on to the studying the impact of location on real estate prices. So what is the impact of a specific location? That is in our case where would be the zip code we have provided in the geographical location. What would be the impact of location on the real estate prices or the housing prices? By examining the data based on zip codes, we gain insights into how different area influence property values. And we will achieve this by grouping data. The first thing we need to do is to group data that help us explore patterns within categories. By categories might mean that we need to do it by zip code. So we can uncover variation in the property values across geographic region. Then calculating the average price. We can calculate the average price for each zip code, creating profile for price averages in different areas. Then we will sort the values by identifying key zip codes. Sorting average prices in descending order reveals the top zip codes with the highest averages. These areas provide insights into premium real estate markets that your stakeholder might be interested to know about. Then we finally visualize this average prices by the use of bar chart. So we will do it right now and you will see it how. The first thing we need to do is to create a variable that is average price by zip. Then we will use df, that is the data frame, and we'll apply the method group by, and we will use zip code and prices. So what does it really mean? That we are grouping the prices based on zip code. I mean, we are grouping the prices based on zip code. For example, let's say there are 20 prices for a specific zip code. So it will group all those houses with that specific zip code. And after grouping all those values for a specific zip codes, all the zip codes, it will calculate the mean value and the average value for each zip code. So that's how we have calculated average housing price for a specific zip code. After we have calculated the average price for each zip code, we will sort these prices from the largest one to the smallest one by using sort values method here. And we want to know the top 10 values of the zip code. I mean, top 10 geographical locations that have the highest average selling point or prices. And after calculating, first sorting the values, then extracting the top 10 values, we would like to print these values. So this purpose we will using simple for loop here for zip code and average price in top 10 zip average prices dot item, and we will print the exam. And then we will plot all the values of zip. I mean, we will plot all the values of prices, average prices for zip code using a simple plotting notation, and we will use a bar chart for that purpose. And when we run this code section, we can see that for we will have the top 10 prices, average selling prices of every zip code, and we will get the associated price. From this data set and results, we can see that zip code 98039 has the highest average selling price of $2,160,000, and so on for the next one. And then finally at the 10th position we will have 98119 zip code. And if we want to graphically visualize that data, which is then we can use this plot here, which has the y-axis it has the average price, and on the z-axis it has zip codes. And we can see the trend that the highest one is the actually 98039, and then we have a sudden decline in the prices, and then there's steep decline afterwards. So this is how you can actually visualize the impact of geographic location on housing prices. Now we have analyzed the impact of geographic locations. You can further now move on to study the impact of housing features. What do I mean by housing features? We will example how various features such as bedrooms, bathroom, wayfront views, and house gates impact property prices. By analyzing these elements, we can better understand the driving factors behind real estate values. The first thing we will analyze is the number of bathrooms and bedrooms. The number of bathrooms and bedrooms in a house affects its functionality and comfort. We will calculate the average prices of different bedroom and bathroom configuration and present that finding using a bar chart. And how do we do that? We will first assign a variable, average price per bedroom, and then we calculate the average price of each bedroom by group using group by. We'll group the values of prices by bedrooms. For example, if there are multiple houses, and some of the houses will have 3 bedrooms, some of the houses will have 5 bedrooms. So example, let's take the example of 3 bedrooms, the houses that have 3 bedrooms, and there are 100 houses. What this group by function will do, it will like group all the houses which have 3 bedrooms, and then it will calculate the average by using this mean method. So you get the idea. We are actually calculating the average price of house which are grouped by bedrooms. And in order to plot it, we will use the simple plotting notation, and we will on x-axis we will have average price per bedroom, and for y-axis we will have average price per bedroom dot values, index and values. So okay, so you get the ideas. And this is the plot we will get. We will have average prices on the y-axis and number of bedrooms, and we can actually see that as the number of bedrooms increases, the average selling price of a house also increases, and we reaches a maximum of 8 bedrooms. Then I see a sudden decline, that after 8 bedrooms there is a sudden decline in prices, and as we go on I can see that there is a trend is declining. So this is actually a good representation, and you can based on this finding you can actually present a good data story. That might be possible that most of the people are that are looking for luxury are actually looking for somewhere around 7 to 8 bedrooms. This could be the most optimum point of property that we invest in if if your stakeholder was an investor. Okay, and we will do the same for bathrooms. Okay, and like we will calculate the average values of prices that are grouped by bathrooms with using the same notation by defining the variable, then using the group by function, then plotting these values. And this trend is actually more linear, that as the number of bathroom increases, the average selling price of the house also increases, and they both reaches even the bedroom and bathroom, the optimum value tend to be 8 number. Okay, now we have identified like bedrooms and impact of bedrooms and bathroom for house selling price. The next thing we want to study would be the waterfront views. Houses with waterfront views are often associated with luxury and scenic beauty. We will calculate the average prices of houses with and without waterfront views and visualize the premium associated price with the waterfront properties. And in order to do that, we will use the same notation that we first define the variable, then we use df, that is the data frame, and then we use the matrix group by, and we will group the prices of houses by waterfront. Then we calculate the average value here, and you plot these values by using dot index and dot values, and we can actually see that we do have only 2 values, that is either the house has a waterfront view and either the house don't have a waterfront view. And you can see that this is quite a significant difference in the housing prices, the houses that has a waterfront view and which don't have. And this is again a more important finding that can be present to a stakeholder. But to keep that in mind, that is another important aspect of data visualization. For me, it's not a complete graph because it doesn't give me an information. What is the actual difference? Like it could be in a percentage difference, or could be anything like a more visually appealing graph. So we can do we can create either notify that the actual value here, and only we could calculate that this is the percentage difference, which will give a more better data story and help your stakeholders, your audience that you are presenting to, a better view on the idea you have explored or identified. So okay, after that, we want to study the house grade impact. A house grade reflects its design, structure, and quality. We will analyze how different house grades relate to pricing variations and present our finding using visualization. And in order to do that, we will use the same group by function method, and we will group the values by grade, and we will calculate the average values. And we can actually see the similar trend here, that the house grading increases, the average selling price also increases. As the house is more quality oriented, has a more quality features, the average selling price of the house also increases and has a higher selling value. Okay, we have studied up till now. We have studied the impact of geographical location. We have studied the impact of housing features. Now, the most important feature that we could study here is the impact of living space and price. Okay, the square footage of living space directly influence the property value, and we will use scatter plot to show how relationship between living space and price manifest. So actually think of it like this: when a seller wants to buy a house, he will actually look at what is the average square foot living area of that property. So this is one of the most important aspect when the house is being sold. So we actually want to study that impact here. So for this purpose, we will use a scatter plot by using Seaborn library and using scatter plot function here, and x-axis will be the square foot of living space and y-axis will be the prices. Keep that in mind, it's not an actual average price, it is actually this is plot is the value of all houses that are present in our data set, and we are plotting it against square footage of living space. And while visualizing that, we do see a trend that as the square footage of living space increases, we do see an increasing trend in housing prices. But there is a one thing more aspect that we have identified, which is that if you look at this any like value, like let's take an example of this 4,000 square footage of living space. For the given square footage of living space, we see there is a huge variation in the housing prices that would range from like 0.3 to 0.4 exponential 6 times the dollar amount. So from this analysis we conduct that okay, we need to further drill down in investigation and analyze what are the factors that actually causing this much amount of deviation or causing this much amount of distribution. And you have actually studied those impact actually, right? If you go back and study that okay, for a given amount of living space, a house can have a different number of bedrooms and bathrooms. A house can have a waterfront or cannot have a waterfront. The quality of house can also be vary. So these are all the factors that would have impacted this price variations. And one effective way to visualize that variations of different features on this scatter plot is actually to like color those scatter plots by color. And we have done the same thing here. We have used the grade as an example. The house has a grade from 0, which is the least graded house, to the 4, which is the highest quality or highest graded house based on some standards. And what we have done that we have actually taken the previous plot here, which is the scatter plot between prices and the square footage of living area, and we have superimposed those dot points with colors of the categorical data of grade like 0 to 4. And while after doing that, we do have some like answer to our question, okay, what causes that much variation for a given square footage of living area. So we can see that the houses that has like grade 4 quality tend to have highest value or highest selling price as compared to the house which has 0 grade. So this is again, this is just one of many examples. You can do that for other things, like you can do it for bedrooms and bathrooms, and you can do it for like waterfront views or no waterfront views to superimpose this scatter plot with those meaningful answer plots to get the meaningful answers. Now we will like study the impact of annotations and condition, and this is an interesting one because it will allow us to like do furthermore calculations. Property condition and annotations can significantly affect a house value. We will analyze how these factors impact prices and present the results using bar plots. So in order to calculate the condition, we will use the same notation as we had done earlier, average price by condition. Then we use the method group by to calculate the averages of prices by condition and group them by condition. But for the renovation, other thing, that is the renovation. If you look at the data set year renovated, we have actually two types of data, and we have either 0, which indicates that the house has not been renovated. Then we have value like any year, specific year like 1991, 1995, indicating that this house has been renovated in some year. So from this data we conclude that okay, so we can categorize the data set based on how we can categorize the properties houses based on either they have been renovated or they have not been renovated. For this purpose we will introduce another column in our data set and we will rename it as renovation status. And how we do that, we will use that by this using this notation. We will use the df data frame notation and we will introduce the column name that we want to introduce. This is just one method of introducing a column name in it data frame. You can use another method, but for right now we will use this thing. If you want to include another column name, add another column to a data frame, you will this notation like df, then you define the column name. Okay, now this is the column name that is suppose that this column has been created, but it needs values to be incorporated into the column. And how we do that, we will use the assignment operator okay is equal to, and we will perform some operation here. And how we will perform this operation, first we will take the values. Think of it like from the logical point of view, we will take values here, year renovated. We will take column from df year renovated that has this value 0 1991, and we will after taking those values we will apply a if and else logic. Then we will say that if the house year, we are calling it as a year, is greater than 0, it means that there is some value associated in that specific row. It could be 1991. Then we will say that this house has been renovated. And if it is not equal greater than 0, it means that the value is actually 0. So we will assign a value no renovation. So this is how we use using apply method we can fill those renovation status to renovation non-renovation. And after we have done that, we will use the same basic notation we have always been using here, like average price by renovation. And we will use df.group by function, and we will group the values of prices by renovation status, whether they have been renovated and non renovated, and then we calculate the average mean value. And after we have done that, we will like to plot the both graphs here. The first one is for the condition of the house prices, and the second one is the impact of renovation on houses prices. And for the condition of house prices, we have 0, 1 to 5. We see that the condition 1 and 2, there is not much a different in the house prices. But as we go to 3 and 4 and 5, they do have a higher price as compared to 1 and 2, with 5 slightly being more on the higher end when it comes to housing prices. And when we now we'll study the impact of renovation on house prices. So we have one column that is the no renovation houses that has no renovation, and we have another column that houses that are with the renovation. They mean that have been renovated in some year. And we can say that there is actually some amount of difference in the selling price, average price of the house with or without renovation. So this is how you study the impact of renovation. Okay, so you have done all the important analysis, exploratory data analysis for getting an idea about how the features of this data set are impacting the house prices. But before we actually dive into deep learning, you see that in data science predictive modeling, understanding your data set is crucial. Before creating a deep learning model for real estate price prediction, we will start with thorough analysis. Think of it like building a house. You need to know the terrain and materials. Similarly, a data scientist studies data before making model. This analysis should give us key goals. This analysis has key goals in order to achieve while performing this analysis. The first one is feature understanding. So performing preliminary data exploration, we will know each feature distribution, range, and behavior. This helps select relevant features for modeling. Then it will also help us to study the feature relationship, how one feature is related to another feature. Then it will also help us to identify outliers outliers can affect predictions, use histograms and scatter plots to find anomalies. Then we have feature selection. Remember that not all features matters equally. Correlation insights help us choose influential features for accurate modeling. Then we have like it can help us to validate assumptions. These analysis checks data assumptions, giving us a clear understanding of data set inaccuracies. I mean, like if you have taken some assumptions, okay, in your mind, or whether it's a formal assumptions like this data set is valid, or the impact of this feature is not as much as compared to the other features. By doing this data exploration, we are able to validate those assumptions. Finally, above all, it will help us better design a model that will help us to predict our real estate prices. So the first of step in like data exploration, we will use feature distribution histogram. We will start by looking at histograms that show different features that are distributed. Histograms provide a concise overview of data distribution. Analyzing these histograms help us understand the structural tendency, separateness of the data, potential outliers within each feature. This step helps us grab the data characteristics before we start building on our model. In order to plot histograms, we will use this method here, df, which is again our data frame, and we will first define the number of bins, that how many data you want to take for the bins, and we will use the simple like title of the plot, the histograms for feature distribution and font size. So after using this quotes block, we will have like all the histograms plotted for each column type. And if you look at that, there are a histogram of all data types are present here. For column names, the date is there, price is there, bedrooms in there, bathroom is there, waterfront is there, view is there, condition is there, grade is there. So what it actually does, it will help us understand how our data is distributed, and then wonder what range it is distributed. If you look at the price, for example, you can see the majority of price is distributed somewhere around 1.3, 1.5, or something like, or even 1 exponential 6. So, and if you look at the bedrooms, we can see that actually the bedrooms are somewhere distributed. The total, the maximum of frequency of occurring of bedrooms is somewhere around 5 bedrooms or 3 bedrooms, and you can study the other things that. So it will help us understand the distribution of data, how our data is distributed, and like from this data we can like use our in data analytics intuitive mindset to help us understand and grasp the data set, that how these features are affecting housing prices. An overview of the data sets. Like after like you have plotted this histograms, the next thing we will plot is the coloration heat map. Coloration is a key concept in data analysis. A coloration heat map visually displays how features are related. A heat map uses color to show positive and negative relationship between the features. So what is coloration, you may simply ask. Coloration is actually like, okay, there are certain aspects of the features, like we have, for example, we have number of houses and price, and we want to think like, okay, what is the actually the impact of number of bedrooms on the price? What could be the impact of location of house properties to the price? So this impact, this relation is actually in statistical term is named as coloration. So coloration will actually give us the idea, okay, how much dependent this value is on other value. So this is what it means by coloration. And heat map is actually, again, we are using color to distinguish between the highest value and the lowest values. So by exploring this heat map, we can identify potential connections and interactions that might impact real estate prices. This might guide us in selecting important features of our predictive models and detecting multi-collinearity. So in order to plot a heat map, we will use the Seaborn library, and we will use the method heat map. Then we will use df.core method here. So go for coloration, and this will like calculate the coloration of all features with all one another. And when we plotted that, you can see that this is actually very good visual representation of coloration, and I will drill down it with you. And as you can see that we have number of colors here in the plot, then we have some associated values, and we do also see that there is either positive value or negative value. So you see that it first of all it has a number of colors in it, then it has some positive values and it has some negative values, and in x-axis you see there we have some column names, and on the y-axis you see also have a column name. So first let's talk about the color math, the color. So the color is actually the demonstrate the value that is associated with it. So for like very bright color or white color we have -1, and then it reaches down to -4 and -5. So color actually denotes the value or quantity of coloration that is associated with that quantity. So you get the idea of color. Now we have like what is the actual value, like -1 to 1. So basic coloration value can vary from -1 to +1. And when we talk about -1 coloration or coloration that is negative, it actually indicates that this feature actually do have a negative effect on house prices. For example, let's take an example. You can take an example which indicates the house's quality is very bad. For example, if there was any column name that indicates that house quality is bad, and we have graded the quality from 0 to 1, with 4 and 5 would be the most third class house quality, then this would have a negative coloration. On the other hand, if there was a positive coloration, it means that this feature has a positive impact on housing prices. For example, let's take another number of bathrooms, and let's take an example of number of quality or grade of that house. They both have like a positive aspect to the house prices. So they are positive colorated, so they tend to have a positive coloration. And the one important thing more to note that coloration can vary from like 0 to 1 or 0 to -1. When it has a value of 1 or -1, then means that the coloration is quite strong, and means that actually this feature actually do contribute to the housing price. If this coloration has a value somewhere around near to 0, it means that this feature doesn't have any kind of coloration, or the coloration is not so significant if you want to say statistically on the housing price. So that's what it means. And okay, now let's turn to y-axis and axis. Well, let's say you want to study the price coloration of price. You see that this is the price column here, and for each price we have some associated coloration with other features. Like zip code, there's a coloration of -0.053, and year renovative, there's a strong, very less coloration of this. But if we want to like look at the positive that has strong coloration, for example here 0.7. So price has a very strong coloration of square foot of living area. So this is how you read a heat map, and I hope you have now better understanding. So like okay, in the previous plot we have actually plotted the coloration of every value, but what if you are only interested in finding the coloration of price to other features? So we can also do that, and we can like use the same method df.core to calculate the value of colorations, and then we will specify then we specify a specific column that we want to find the colorations. So we, in that case, we are using price. So df.core, and then we are specifying the column that we want to calculate the coloration with other features. And finally we are using drop. Drop is just for like dropping the values we don't want to plot in our graph. So we are dropping price, longitude, latitude, and ID, because these coloration is more of a numeric relationship, like a numerical column that has two columns that are numeric, has the numerical data, and those columns make actual sense. But longitude, latitude, and ID are actually categorical data, so they are not that much like that's why we dropped it. And another thing, like we also drive price, mean the coloration of price will be price nothing, like it's okay, it's 1, because they are like comparing one thing to the same thing, so that's why we have dropped it. And after like calculating the calculation values, we will like sort the values from the top one to the lowest one, and then we will use the same plotting notation and plot a graph. Now this thing will now give us a more better understanding how house prices are affected by many other features. we see that the square foot of living area has the highest impact on prices. Then the grade house of grading has the second highest impact on this. And as we move on, we can see that the square footage of living area, the features that are related to the square footage, have more better impact on housing prices. But we do see other features like the views, the floors, waterfronts, bedrooms. They also have a positive impact. And on the very last end, we see the housing condition. And we do have identified and verified that when we plot our impact, we have studied the impact here of housing condition. We do see that there is not actually a much of relationship between housing condition from that 1 to 5. So there is not much of a strong correlation, and we can also see that here in our correlation plot. So up till now, give yourself a pat. If it was for a data analysis study, it was a project like a data analysis study. You have done all the requirements that are needed in data analysis, and you are good to go with all the findings you have find. Then present an effective data story to the stakeholders. And you have studied all the impacts of features on housing prices, and you have done statistical analysis. You have done some distributive analysis, and you have graphically visualized those things. And one more thing, like if you want to further enhance the visualization, there is a tool called Tableau. It's a quite effective tool that will help us plot data without any need of programming and coding. I know some people don't like programming, so for this purpose, like they have Tableau. You just upload the data, you make the connection, and you do some amazing and stunning visualization on it. I do have a video on that will give you the fundamental building block for Tableau, how to use Tableau, and I have plotted some features on it. So go check out that video. I will put the link in the description. So after that, let's move on to creating a deep learning model. Now we have come to the final challenge of our project, that is actually to create a deep learning model. And the first stage is to actually prepare the data for training. What do I mean by preparing the data for training, and how does it differ from the actual data pre-processing stage, where we will actually clean the data, we will actually standardize the column names? Well-prepared data set is crucial for building accurate models. Now I will outline the essential steps for preparing data before training a deep learning model. The first one is called feature selection. We carefully choose relevant features that significantly influence real estate prices. These selected features such as bedroom, bathroom, and square footage become the model's input. So this stage we will define, okay, what based on our previous analysis, or data analysis, or exploratory data analysis, or correlation analysis, what are the important features, and what are the features that we are going to take as an input to the model. For this model, we have identified 7 features like bedrooms, bathrooms, square foot living area, square foot floor, square foot above, and basement. And we have created a list by using and assigned it to selected features variable. Then we have taken out the values from our data frame, only those columns that are present in selected features, and we have assigned value to X. X is actually the training data sets that will be used by the model. And then we have a Y, which is actually the predicting variable Y, that is the housing prices, and we have assigned it to Y. After we have selected the feature, the next important thing we need to do is to scale features and target. To ensure fair comparison, we will use min-max scaling to standardize features and target variables, priced to a common scale, enabling the model to treat each feature equally during training. So for this purpose, we will use scikit-learn library, and the function is called min-max scaler. And we will assign it to scalar variable, and we will use the method fit transform, and we will pass input argument rx, that is the selected features. And by doing so, the features will be standardized and will be converted by scaling. And we will do the same for our target variable, that is y, but before we do that, we have to reshape the y and then finally use fit transform to actually scale the parameters, target variables. So right now we have selected the features, we have scaled features and target value. Now we will split the data set into training and testing. We will divide the data set into training and testing. The training set is used for model training, while the testing set evaluates the model predictive abilities after we have trained the model. For this purpose, we will use a function train test split, and we will pass the input argument x scale and y scale, which are the scaled values of features and target value, and then we will define the distribution or the separation quantity, which is 0.525. So by 25 means that okay, we want to assign 25% of the actual data set values to the testing phase, where we'll test values after the model has been trained, and we will keep the 75% values for the training phase, where we'll use features and predicted value y for the training model. And you can see that the size of training data is 75% and the size of testing data is 25%. Now our data is now primed for deep learning model training. These steps establish a strong foundation for accurate real estate price predictions. We have prepared the data to move forward with model training and validation. So we have prepared the data by using feature selection, scaling, and splitting the data into training and testing. Now, as we have data prepared for insights, we have prepared the data, we are now ready to create deep learning model. And for those who are very less familiar with deep learning, let's take a moment to understand the key concepts and steps involved, how a deep learning model is created, how it is defined. So deep learning is a subset of machine learning that involves the use of our artificial neural networks, which are inspired by human brain structures and its working. These networks consist of layers, building blocks that processes and transforms data, and the core structure of deep learning model is such that it first contains the input layer, which is the entry point for data into the network. This is where we will push our data into more deep learning model, okay, and we will give it as an input, and it receives the features of our data set. Whatever the features we have assigned, it will receive as an input. Then we have hidden layers. These hidden layers are intermediary layers that process the data through a series of mathematical operations, or in more specific terms, statistical operations. Each layer extracts different level of abstraction from the input layer. And finally, we will have the output layer. This is the final layer that produces the model prediction or classification results. It means the deep learning model will take selected features as an input, then it will process it through a number of layers, then it will use the output layer to give the final output variables. Okay, what would be the predicted price? So without further ado, let's talk about the actual code here. So in this code, we see that we are using the Keras libraries to create a sequential model, and this type of model allows us to stack layers in a linear sequence. So this is the sequential Keras library. We are using sequential method, and what it does, it will allow us to add layers in sequence, step by step. We will define input layer, then we define hidden layers, then we define model add layers, and for every layer we want to define, we will use this method model.add to actually add the layer in the deep learning model. For the input layer, we will define input dimension is equal to 7, which specifies the number of inputs that we want to give to this model. If the number of features were to be different, for example, let's say 15, 19, then this input dimension will be changed accordingly. And furthermore, the layer also uses ReLU, rectified linear unit activation function, a common choice for introducing non-linearity. When we talk about hidden layers, they consist of 100 neurons each. You see that we have defined 100 in the input argument, and they also contain activation as ReLU, and you see that here. And then we have the output layer, which has a neuron of 1 and activation as linear. And after defining the model by using model.add method, we will to see the model summary, and for this purpose we will use model summary. And we can see that we have actually one dense layer, input layer, then we have two hidden layer, then finally we have one output layer. Now we have defined our model using Keras library. And now we will compile the model. Compiling the model involves configuring the learning process. It specifies the optimizer. In our case, we have specifies the optimizer to be atom, a popular optimization algorithm, and the loss function to be mean square error, a common choice for regression tasks. A loss function quantifies how far off our predictions are from the actual value. So those are people who don't know about the mathematics behind machine learning. Actually, machine learning is actually just an optimization problem, and we have number of algorithms that optimize the value, and they optimize a function or value for certain specific tasks. In our case, it will be the mean square error. That will be the difference between the actual values and the predicted values, and subtracting the difference between the actual value and the real values, predicted values, then taking the square root. So this is this is how optimization work. Like automation algorithms tend to minimize the loss function, and after each iteration they minimizes the loss function such that our prediction gets more accurate or more reliable with good accuracy. Now we have compiled the model. Finally, it's time to train the model. To train the model, we'll use the function model.fit and with the scale training data. Remember that we have transformed the data into scale quantities. So we will use scale quantities of features and the predicted value. The model adjusts its parameter over specified number of epochs by iteration, minimizing the loss function. The batch size determines how many training examples are used per iteration, aiding the optimization. So with each iteration, the optimization algorithm will minimize this loss function, and after for example, it will choose those parameters for the model that will help us better predict the model. For example, let's say it was a regression, it will calculate the values of what are the optimized value of p and slope. So in this case, this just like that for deep learning model, every iteration or every approaches, it will minimize the loss function. And you can see for every iteration it gives us the loss function here. Now you have trained the model, and there are some key important features that we can get out of this training variable. If you look at this, we have trained the model and stored it into the variable purchase hits. There are a number of things that we can get out of this variable beside doing the prediction. In the field of deep learning, training a model involves an ongoing process where it improves the prediction by learning from data. An important measure of this progress is the loss function, as we have discussed earlier, which shows how well the model predictions matches the actual values. As we go through the training iterations or approaches, the loss should ideally decrease, indicating better model performance. So we do want to actually visualize how this loss function decreased after each iteration. So we want to visualize that behavior on this. So we can graphically visualize that. In the following visualization, we will show how the model loss changes over each approaches. And the x-axis will represent the approaches of the iteration, while the y-axis shows the loss value. There are two lines are plotted: the training loss and the validation loss. The first line reflects the model learning from the training data, and the second evaluates the performance on unseen validation data. So this is the thing of In the following visualization, we will show you how the model loss changes over each approaches or iteration. The x-axis represents approaches or iteration, while the y-axis shows the loss value. There are two lines that are plotted. First one is the training loss, and the second one is the validation loss. The first line reflects the model's learning from training data, and the second evaluates its performance on unseen validation data. So in order to get those values for each iteration, we will first use a variable that is approach history that contains our model, and it also contains the historical data, how the model was trained, what was the loss value after each iteration. And then we will use the dot notation and history. Then we define the column name here loss, and then we will label it as training loss, and we will do the same thing for validation loss, and we will label it as validation loss. Then we will do the other necessary plotting notations like title, label, x label, y label, and ages. So you can see here that we have our plot here, model loss progress during training. Then the x-axis we have purchase or iteration, and we have loss. And you can see that after each iteration, the loss or the difference between the actual value and the predictive value gets smaller and smaller with each iteration. So what crucial insights you can get out of this plot? The first one is like a decrease in both line indicates the model is learning and adjusting its prediction, and if it's getting flat means the model has fit and is actually been trained good. And if we see a sudden drop in training loss occupied with a rise in validation loss, this will suggest overfitting where the model becomes too tailored to the training data. We have graphically visualized the historical data, like how our model was trained and what was the loss function and what was the validation loss function and training loss function during each iteration. But right now we are more focused on actually visualizing, okay, how will a model will predict the values. For example, if we given a set of number of features like bedrooms and apartments, all the things that we have defined as an input to the model, how well it will predict the values. For this purpose, you remember that we have actually split the data into testing and training. With the training, we have actually trained the model. Now we will use that testing data, more specifically like the features of houses, and we use that housing feature, and we will use input to the model, and we will predict the values of prices of houses, and we will store it into the y predicted variable here, and we will use the method here predict, and we'll pass the input argument are the testing features of the houses, and we will get out the values of prediction. And after like we get the values of prediction, we will like plot these values against the actual values. So we will use the simple plotting notation, and we will on the x-axis we will plot the two values, and the y-axis we will actually plot the values that have been predicted by the model. And you can see that the model hasn't actually predicted the values quite well, and we see there's a quite a variations, and I will explain why we are able to see this variation in the next plot. So if you remember, this actually data is actually the transformed data. This is not actually the true values. If you can see that the actual true values were actually in the form of dollars, and they were in kind of millions of dollars and thousands of dollars. But these values are coined in the decimal, like from 0.1 to 0.7. So we need to transform back this value to actual values that are actually dollars. So how we can do that? We will use the function method, that scalar inverse transform, which will transfer those values back to the actual values, and we will then store them into y predicted original, like which was the predicted price by the model. Then we have like y test original, that the original values of the houses corresponding to the features, and we will use this method inverse transform. And now we will plot two things. First we will like plot the second scatter plot, which is the values of true values and predicted values. Then we will also plot the diagonal line. And why we do plot this diagonal line? Well, this diagonal line actually indicates the ideal prediction. It means that this if the point was to lie on this diagonal line, it means that the predicted housing price of our model is actually a true value. I mean, the true value and the predicted values are equal. So that's what it means. Okay, if the values lie quite close to the diagonal or lies on to the diagonal line, means our model has predicted quite well. And but you can see that there is actually quite variation. For example, if you take this example here, which is the true value at 3, but the model has actually predicted the value to be somewhere above 4. So this is quite a false prediction. And so what are the insights that we can get out of this graph? First, again, point close to the dashed line indicates accurate prediction. Points above the dash line means the model underestimated, while points below it's overestimated. Points scattered around the dash line show different values of accuracy across prices ranges. Okay, we have graphically visualized that data, okay, and we can get this, and the model is actually not predicting well. But what are the performance metrics that can actually or statistically define that this model is actually not a good model? So we have number of more parameters where we can assess the performance of our deep learning model by using key matrices. These matrices help us understand how well the model has predicted the real estate prices. Performance matrix gauges the quality of predicting model's output. They show how well the model prediction matches the actual values. By quantifying prediction errors, we can measure accuracy, precision, and overall efficiencies. Following are the performance metrics. First one is root mean square error. Root mean square error calculates the average magnitude of predicted errors. It is the square root of average square differences between the predicted and actual value. Then we have mean square error, calculates the average of square prediction errors, providing the insights into model deviation from the true values. Lower MSE indicates greater accuracy. Then we have R square error and other values as mean square absolute error, R squared coefficient of discrimination, which is then we have the most important R squared coefficient of discrimination. R squared measures how much variance in the target variable the model explains. Higher R squared values suggest better predictable quality. And then we have adjusted R square. Adjusted R square contains R squared and the number of features. It offers a nuanced view of model fit while penalizing excessive features use. So it's like, okay, we have a set of, we have taken a set of features, and we like the features that we have selected are more than what is needed for the deep learning model. So this will like penalize the R square value and give us just an estimate. Okay, you have actually used more features than it's needed to be. So that's what it means by penalized. So we will use only two things. We will need only two things. That is the predicted value and the actual Y value. So in order to calculate all these performance matrices, and when you have calculated these performance matrices, we can actually see that R squared or coefficient of determination is actually 0.562, which is quite low. So we need to perform some steps there that can actually enhance the performance of this model. So in the world of predictive modeling, continuous improvement is the key. The process of model enhancement and optimization involves refining strategies to boost model performance. Here we highlight the crucial statistics for maximizing predictive power in deep learning model. The first one is feature enrichment. Enhancing a predictive model begins with expanding the range of features. More features often a better understanding of underlying data patterns. This section demonstrates adding various features like living space, bedrooms, location to enhance predictive capabilities and capture hidden nuances. For example, like there are some patterns we are not able to identify through our exploratory data analysis or data analysis case studies. So by enhancing the features, deep learning will automatically capture those nuances and help us better predict the results. Then the second thing we can do is called architectural evolution. The model architecture shapes its learning process. By adding hidden layers, we introduce complexity, enables the model to learn more, more better relationship between the features and predicting value. That is the target price value. Our guide is, and then we have the hyperparameter adjustments. Fine-tuning a model involves adjusting hyperparameters that governs the learning behavior. This includes experimenting with different learning rates, activation functions, and optimization methods. Hyperparameter tuning specifically impacts model effectiveness and its critical step in optimization. So there are a number of things we can do in order to enhance the model performance. First, we can include furthermore features, or we can add more layers to the model, deep learning model, or we can further fine-tune parameters like choosing a different optimization method instead of the add-on. So obviously there's some problem there. One optimization algorithm might not perform well as compared to the other. So these are the things that we can do in order to enhance the performance of our model. So right now I will present you a case study where we'll enhance the model performance, and we try to increase its performance and prediction, and also increase the R square value somewhere around 0.85. So the first thing I have done, we should do increase of features, housing features. Like instead for going for 7 features, we could go for 17 or 18, 19 features. So as you can see, like right now, I have increased the number of features from 7, and there are more features right now. And like after selecting the features, we will do the same procedures as we have done earlier. We will like define the x and y variable, then we will transform those x and y values, and then we finally split the data into training and testing. So we have selected more features as compared to the earlier, and then we perform the same operations. And when it comes to model architecture, we have actually add another layer, hidden layer, as compared to the previous model, and we have increased the number of neurons. In the previous model we have like 100 neurons. In this model we have defined 200 neurons, and our optimization algorithm remains the same, Adam, and the loss is remains the same, mean square error. And we will use the same functions to train the model using model.fit, and it will like train and iterate our hypothesis, as you can see here. And one more important feature, like we can use a summary.method here, model.summary, to actually see what kind of model we have built. The first one is input layer, then we have 3 hidden layers, and finally we have an output layer. So like after training the model, we actually want to plot historical data. What is the training loss and validation loss during after each iteration in the plot? And when we visualize this thing, we can actually see there is a quite difference between in this graph and the graph we received earlier from the previous model. We see that the loss has actually way less value, smaller value as compared to the previous model, and it kinds of gets steep and gets constant as we number of hypotheses increases, which is also a good indication. So so it is a good indication that a model has actually performed well, or could have performed well, as the error of validation and error of training loss is quite low as compared to the previous model. Okay, now we want to actually see the predicted values, that the housing values that have been predicted by the model using the features we have assigned for the prediction or testing. And then we will use the same like method like model.prediction, and then we pass the input features. Note that now these features will have all the features that we put into the will have all the columns that we have first assigned that will go into the training of the deep learning model. So instead of like having just 7 features, they will have all the features that we have first assigned in the feature selection phase when we want to optimize the model or enhance its performance. And we have converted that into actual values using inverse transform, and we have plotted this line here. Now you can actually see that the values actually do align and fall very close to the diagonal line instead of the previous graph. If you can look at the previous graph here, the values quite not lies very near to the diagonal line, but on the second model where we have enhanced number of features, and we have another layer and increase the number of neurons, we see that actually the values are now quite close to the diagonal line. And now we can see that I have graphically visualized, but we want to statistically see it or through some value, so we can use r square value or coefficient of determination value. So we do actually see that the r square value has increased to 0.85, which is also a good indication. So if we recall all this case study, first of all, we have imported the important libraries that are needed to carry out this data science project. Then we have imported the data and used the correct encoding. Then we have imported the data set, and then we have get an overview of the data set. We have used like functions and methods like df.info and df.describe to get a statistical overview of the data set. After that, we have like pre-processed the data where we have standardized the column names, and we have changed the date time format, and we have checked the data set for null values or duplicate values. This is the primary step for any data science or data analysis case study. After we had done that, we have moved towards exploratory data analysis, and we first have get our hand dirty on descriptive analysis. Then we study the impact of geographical location of housing prices, then the housing features impact on house prices, and finally we have like explore data and study the correlation of one column to another, and specifically we were interested in studying the correlation of price to the other features, and we had identified that okay, square footage living area impacts the highest impact. And after that, like we moved towards creating a deep learning model, and that we have first like prepared the data for deep learning model, where we have selected the features, where we have transformed the features and target value using standardization, and then we have split the data into training and testing, and then we have evaluated its performance using performance matrices, and plotted the results of validation loss and training loss. And we from that we see that our model was not actually predicting quite well. Then we have like included optimize the model using adding more features, then adding more layers and increasing the numbers of layers, which actually do impacted the performance of our model. And we increased our R square value or confidence or determination value from 0.5 to actually 0.85, which is quite a significant improvement. So this is how you actually carry out a data science project or data analysis case study. So we actually covered two things, like data analysis case study and data science case study. So this is pretty much it. For example, like if you were given an interview and you were given a case study for a day, so you can actually go back and look at this file and get an idea how to carry out any data science project. That's it for now. Don't forget to like, comment, subscribe to my channel. By doing so, you will be supporting me for creating this kind of content again and again. And you want me to carry out this kind of project in R programming language, just write me down in the comment section. I would be happy to help you out, and maybe the next video will be on R programming language, carrying on the same kind of data analysis or data science project. And if you want to learn Tableau, I do have a descriptive video where I take you from the beginning and I help you teach you how to create visualizations in Tableau. So that's it. Again, an effective resource for any data science or data analysis case study. That's it for now. Thank you for watching it, and don't forget to like, comment, and subscribe to my channel. By doing so, you will be the first one to know about the latest tips and tricks, and that will also help me. You will also support me for creating more awesome content like this. Thank you for watching this tutorial, and I will catch you soon in the next one.